Well, good afternoon. My name is Dwayne Brown with NASA Headquarters Office of Communications. We're coming to you from the Newseum here in the nation's capital. Our first briefing featured assets and being prepared. The second and last briefing is about the science. You really don't want to miss this. We've got some very, very excited and some pretty interesting things happening in the science community. We'll have brief presentations, then we'll open it up for questions starting here at the Newseum and on our phone lines, and of course, social media. Social media, hashtag Eclipse 2017, but also everything that you hear and much, much more on the websites at NASA, eclipse2017.gov and Eclipse Live. And remember, nasa.gov/Eclipse Live, the live NASA television for the August 21, 1999. Sorry, 99 years in the making. I've got a lot on my mind here. I'm waiting for the scientists. They got me excited. 99 years in the making, a total solar eclipse across America. We're going to talk about the science. I'm going to introduce our panelists, and then I'm going to turn it over to Thomas, who has joined us again. And he's got his interesting attire on. He's changed on me today. And of course, social media, send those questions in, hashtag Eclipse 2017, and we're going to get to those. So I'm excited about the science, so let me introduce you to these incredible scientists. Thomas Zurbuchen, back again, nice red, I think that means something there. The Associate Administrator for Science Mission Directorate at NASA Headquarters. Angela Desjardins, Principal Investigator of the Eclipse Ballooning Project at Montana State University, Bozeman. Going out to the West Coast, Linda Shore, Executive Director of the Astronomical Society of the Pacific in San Francisco. Dave Bobolts, Program Director of Solar Physics in the Division of Astronomical Sciences at the National Science Foundation in Arlington, Virginia. Angela Speck, she has many titles, Professor of Astrophysics and Director of Astronomy at the University of Missouri, Columbia. Matt Penn, astronomer, National Solar Observatory in Tucson, Arizona. And with that, to facilitate the discussion, I'll turn it back over to you, Thomas.
Well, I'm really excited to be part of this panel just because science is such an important part of being an eclipse. And I'm going to kick off some presentations here about specific topics. And Angela, I'd like to start with you, really talking about observing the eclipse from the edge of space. Go for it, Angela.
Absolutely. The goal of the Eclipse Ballooning Project is to connect to a basic human sense of wonder by providing live footage from the edge of space. So how did this edge of space footage come about? How did the idea come about? About 4 years ago, I was doing my daily perusal of the news, and I saw a story about a pilot who accomplished the really difficult task of getting his plane in just the right place at just the right time over an ocean so that his passengers could see the total solar eclipse from the air. My first reaction was, why would they do that? Why would they not just sit in a boat in the ocean and wait for the eclipse to come across? There must be something special about seeing the eclipse from the air. So I thought about that a little bit and thought, if the eclipse is more interesting from the air than from the ground, what would it be like from a high altitude balloon where you can see the curvature of the Earth and the blackness of space? I did some research and I found out that one group had taken footage from a high altitude balloon of a total solar eclipse before with a GoPro from Australia in 2012. And indeed, the footage from that vantage point, seeing the shadow of the moon crossing across the Earth, was spectacular. If you can show the first video, please. This is some footage of some students launching high-altitude balloons. So with my work with NASA Education, I also knew that there were over 100 student-led high-altitude ballooning programs across the country. So the idea occurred to me that we could bring these student teams together and provide awe-inspiring edge of space footage to the public for the 2017 total solar eclipse. But I knew that for the footage to really have an impact, it would have to be live. Therefore, we took the NASA Science Mission Directorate and NASA Space Grant and teamed them together to create the Eclipse ballooning project. A project that at the time, we had no idea how to do. Nobody had ever live streamed video from one high altitude balloon of a total solar eclipse before, let alone dozens across a continent. Luckily, an affinity for solving tricky problems is exactly what draws students into science and engineering fields. If you can play the next video, please. So after a lot of hard work, we have over 50 student teams from across the country ready to stream high-altitude video from dozens of locations across the path of totality, sharing inspiring, imagination-sparking footage with the public live. We hope you check out our footage on Eclipse Day. Thanks.
Thanks so much, Angela. And what I'm going to do now is kick it over to Linda, who is talking about taking this eclipse as an opportunity to learn and also to inspire the next generation of scientists. Linda, take it away.
Hi, thanks. It's great to be here. So I wanted to talk just a little bit about not the current eclipse coming up, but one from the past that was really interesting to forming my society, the Astronomical Society of the Pacific, and I think it's an interesting one to look at in terms of the science. Every eclipse tells scientists something new about the sun and allows scientists to use new techniques. And this eclipse is no different, and the scientists on the panel are going to talk about that. But think about eclipses prior to having photography. Eclipses were studied, the beautiful corona was observed, but you couldn't photograph. What they did was they sketched. Scientists would sketch. And I thought about that, and I realized, well, that's kind of difficult. It's pitch dark during an eclipse. Your heart's racing because you're excited, and here you are with a pen trying to sketch the corona, or you'd have to do it from memory. But there was an eclipse in 1889, the New Year's Day eclipse, which passed through California. It didn't go coast to coast the way this one is going to, but it passed north of San Francisco and then took a curve and went through Montana, the Dakotas, and then on into Canada. On that eclipse, there was a group of intrepid amateur astronomers with their telescopes who joined forces with a photography society in San Francisco, brand new. These were folks who got their cameras and were super excited about this new technology. They joined forces and went north into the wine country. And the next slide, or this slide, shows one of the first photographs ever taken of an eclipse. This particular one is a time exposure showing the different phases, the partial phases approaching totality. And imagine how excited this photographer was to develop this plate and for the first time capture the partial phases of an eclipse. This was really remarkable. And what happened after this is the group of amateurs and professionals went back to San Francisco a month later, shared their photographs, shared what they'd learned, and they had such a great time forming this community that they decided that very evening to form a society, the Astronomical Society of the Pacific. And while we were once a small provincial society located in San Francisco, this is our 128th year, now we're a national society, and we're actually dedicated to education and outreach and helping people of every kind, whether they be children, students, teachers, professors, college teachers, rangers, Girl Scout leaders, everybody learn astronomy and be able to share that knowledge with other people. And that's what we're about. So this particular eclipse, and you're going to hear this later from the scientists as well, is going to excite a lot of people. And many of them watching this eclipse may choose astronomy as a career. I did. In 1979, a partial eclipse of the sun was visible in San Francisco. I was a broadcasting major. I happened to be interested in science, and I took a bunch of tools to the student union and showed people how to watch a partial eclipse safely. Most people didn't even know it was happening. So with me, I had eclipse glasses, which are very important for viewing the partial phases, and people were amazed that they could look at the sun and see it. I had ways to project the image onto cardboard using pinholes, using tiny holes, and allowing a single image of the sun to appear on a piece of white cardboard. And then you can have a lot of fun, and if you have a lot of holes, like a colander, you can project many, many, many images of the partial phases. So that got me hooked that day. I decided not only to become an astronomer, but to become an astronomy educator, because it was really revelatory for me to change the lives of these people that were watching the eclipse with me. So let me show you a little bit about what's going to happen for this eclipse. So if I can have the slide. So a lot of you have already seen this. This shows the path of totality across the US, starting in Oregon. In an hour and a half, the shadow will traverse the US and exit in the Carolinas. But what I'd like you to pay attention to are the partial phases. There are many, many, many millions of people who are not going to get to the path of totality because of time, because of money, lack of resources, transportation. There's lots of reasons people can't travel. The eclipse is going to be just as magical for them if we can provide them with the materials they need to see the eclipse safely, and we can use this as a teaching moment. This is an opportunity to reach out to youth across the country and teach them a little astronomy, because as this partial is unfolding. So take a look at the map. You'll see in fact, all of the continental US sees at least a 70% partial eclipse. 70% of the sun will be obscured by the moon. Now find the place where you live on the map. Maybe you live in Detroit, Atlanta, New Orleans, the rural parts of New Mexico. All of you are going to be able to experience this partial. At the Astronomical Society of the Pacific, we particularly are interested in reaching underserved communities and children who represent communities underrepresented in science. We want to make sure that those kids are engaged fully in the eclipse, even if it's a partial, so that they might decide to become an astronomer like I did. So what I have is some examples of activities that the Astronomical Society of the Pacific has developed and disseminated across the country to make sure that kids are engaged. And let me give you an example of one in the interest of time. So what I'm holding up is a scale model of the Earth and Moon on a series of rulers. So let me explain. This is the Moon. This is the Earth over on that side. And you'll notice that the Earth is a 1-inch diameter marble, and 30 inches away, 30 Earths laid end to end, is where we place the Moon. And the Moon is a quarter of the diameter, so this is a quarter of an inch, quarter of a diameter of the Earth. So this is an actual scale model. First of all, you might be surprised, because lots of the pictures and images you normally see, the Earth and Moon are much closer together than this, but this is the actual distance and size. So that's a learning experience in and of itself. And now we can use this to actually model what's going to happen in terms of the shadow of the Moon hitting the Earth and what that's going to look like, because you've got everything to scale, so the sun and the shadows are going to work to scale too. So what you can do is you take this outside, and the tricky part is you use the actual sun in the sky, and you manipulate this stick so that the shadow of the Moon is cast on the Earth. And I can't do that in studio because I don't have the sun right here, but I have a photograph. This is a photograph showing what the Earth ball is going to look like if you line things up properly, which is actually pretty easy to do. And if you look carefully, what I love about this model is the very, very dark shadow you're seeing in the middle of this marble representing the Earth is the total eclipse location. If you live on the Earth in that super, super dark shadow, you get to see the total eclipse of the sun. But you may notice on the outside of the very dark circle is another shadow, not as dark. That's where you're going to see the partial eclipse. And so using this activity, You're learning about shadows, about the umbra shadow, the penumbra shadow, the dark, the light shadow. You're learning about the geometry of the eclipse. You can do a lot of things with this model. And this is just one of many activities that the Astronomical Society of the Pacific has developed and disseminated to rangers in parks, libraries across the country, museums, schools, lots of different places with support from NASA and also the National Science Foundation. So that just gives you some idea of how you can reach kids across the U.S. to make sure everybody is engaged so that astronomy can be diverse and inclusive and a wonderful experience for all.
Thanks so much, Linda. Now, you're going to talk about some of the most amazing telescopes looking at the sun and about space weather. Take it away, David.
Yeah, sure. So one of the things that most people probably don't know is that the National Science Foundation is the steward for all ground-based astronomy in the United States. So NASA does a lot of the space-based stuff, or most of the space-based stuff. We do most of the ground-based stuff. And we do this through our national laboratories. So one of those national laboratories is the National Solar Observatory that Matt Penn works at. And then another of our national laboratories is the National Center for Atmospheric Research. And so they do things like what's shown in my first slide. This is a beautiful image of the sun. And so what one might ask is, why does NSF or NASA or the federal government, for that matter, even care about solar science? What are the sort of things that, I mean, don't we know all the questions? Haven't we answered all the questions about the sun that we would want to ask? And the answer to that is no. And so basically from NSF's perspective, we look at the sun from both an astronomy perspective, from the astronomy division that I work in, and also from a sun-Earth connection, heliospheric connection within our geospace sciences section. And so from the astronomy's perspective, we look at the sun as a star, and it's our nearby laboratory that we can use to study stars like our sun, and then try to expand that to stars that are further away, much further away. And we also look at the sun and its interaction with the planets in our solar system. There's a number of exoplanet systems, planets outside our own solar system that have been discovered. I think the count is over 2,000 now confirmed, and over 4,000 are candidates. And so we want to apply the theories that we get from studying the sun to those exoplanet systems. The other thing is we want to also figure out and talk about the heliosphere and the interactions between the sun and the Earth, especially with regards to space weather. So the sun has all these interesting phenomena like solar flares, coronal mass ejections, the solar wind, and all of those things are collectively known as what we consider space weather. And so next slide, please. And so a lot of that space weather occurs in this region of the corona. And so the corona is the thing that we'll see during the total solar eclipse. And so you can see here's an image of it. And so that's where a lot of the action is. And so Matt's going to talk about his coronal science that he's going to do from the ground with his Citizen Kate project. But the interesting thing is there's a bit of a gap now in the coverage of the corona, especially this nearby corona that we don't see. And that's where we want to use and do science for the eclipse, and use the eclipse for that type of science. Another thing we're doing at the NSF is we have, through our National Center for Atmospheric Research, we're going to fly one of our Gulfstream jets, and we're going to fly it through, as the eclipse is happening, fly it along the path of the eclipse, and use a instrument called an airborne infrared spectrometer, and basically take spectral images of the corona during the eclipse. And then the final, last slide. And so as I mentioned before, we're the steward of ground-based astronomy. And so right now we have 2 different construction projects within NSF. One is called the Large Synoptic Survey Telescope, and that's in South America, in Chile. And that's designed, is going to observe over 37 billion stars and galaxies over a course of several days, and then repeat that over and over again, and it'll basically survey the universe. Another one, the one that I'm involved in, and the one that's important for solar science, is this this telescope right here. It's called the Daniel K. Inouye Solar Telescope, or as we affectionately call it, DKIST. And so DKIST is going to be the world's largest and most powerful solar telescope ever built. And so it's going to have a 4-meter aperture, 4-meter diameter mirror, which is 13 feet across. And so if you can imagine the amount of solar light that we can collect with that type of mirror. And so it's going to be an incredible high-resolution machine it's going to be able to observe the sun at 20 to 30, or pixels on the sun at 20 to 30 kilometers across. And that's really where the interesting science, we're really getting down to the interesting science. And so with that, I'll hand it back to Thomas.
Well, thanks so much. That's truly exciting, what's happening in that telescope and the other things. Many of the stories about eclipses, don't actually just have to do with astronomy, but they have to do with birds, with nature, kind of the atmospheric kind of effects. And Angela Speck, you're going to talk about that. Why don't you tell us about your work?
Thanks, Thomas. So we've already heard a lot about how space and looking at the corona and doing research on the sun itself. And we've heard about engaging with the public. What I'm going to talk about is kind of somewhere in between all of that. So we want to do research on the impact of the eclipse on the ground, that is the atmosphere, the animals and the plants, and also how we can use that to engage the public. In some cases to encourage people to become scientists, and in others to turn them into fans of science. So let's start with the atmosphere. If I can have that first video. We know that over the course of a day, the sun comes up and it goes up to its highest point and then goes back down. And over that time, we get different levels of illumination from the sun. But during the eclipse, we have an added thing that's changing our illumination. So the video is showing you what the illumination looks like as the sun is moving across the sky, and now it is being eclipsed. And so we're getting a decrease in the amount of sunlight. And that's going to have all these multiple effects. So if we start with the atmosphere, you can imagine that as you block out the sun with this big rock, the moon, you're going to decrease the temperature. We know it gets colder when a cloud comes in front of the sun. So now it's a big rock, and the temperature is going to drop. And there's still science to be done in terms of understanding the magnitude of that drop, how it changes across the course of the eclipse. But also that drop generates air pressure changes, which gives rise to air currents. So there'll be experiments being done that will involve measuring temperatures and air currents as the eclipse passes over the US, and that will involve citizen science where we involve the public in collecting data. If we can move on to the second photograph, this is showing you a bird in the sky during an eclipse. It's actually an annular eclipse. But we know that animals react differently at different times of day, and we know from anecdotal evidence from previous eclipses that you get animals interacting with that change in light, and maybe the change in temperature too. So birds, for instance, we know that towards twilight, birds will start doing this swarming around thing, and they're going to be showing you, making lots of noise and showing you that they're getting ready to go to bed, and then it goes dark and they settle down. Well, that's going to happen probably during the eclipse, but different types of birds are going to interact differently. Other animals, we know that farm animals, cattle, will tend to go back to the barn because it's bedtime. Insects that chirp at night or frogs that chirp at night may start chirping once it gets dark. And so one of the things that we want to do is to be able to really collect data. And not only is this going to be done on the basis of universities, like schools that have animal and plant science programs, but also with the public through the iNaturalist app and Life Responds, which is a program out of the California Academy of Sciences, where we want to collect exactly what all these animals are doing as it gets dark. And so even before it gets completely dark, with the change in brightness of the sun, what do the animals do? What do we see? What do we hear? If we can move on to the last slide. Now what this is showing you is how the eclipse interacts with a plant. This is a tree, and as you've got the leaves overlapping on the tree, you're making little pinholes. And each of those little holes acts as a pinhole camera. And so what you're seeing is lots and lots of images of that partially eclipsed sun. And so that's one way in which a plant is interacting with the sun, but that's just visual, and it's pretty cool to see. But some plants will do things at night, like you have some plants like lotuses that will close up. You have some plants, for instance, some varieties of corn will actually unfurl during darkness. And so, as well as looking at the animals and what they do as we get eclipsed, we also want to study the plants. And so there are all these different ways in which we are seeing how our own natural world is interacting with that change in light. And it helps us to understand not only how science is all interconnected, but how much we rely on the sun. And it helps us test some ideas about just things that we do with plants and animals on the ground every day. And with that, I'll hand it back to Thomas. Thank you.
Thanks so much. So Matt, you know, some of the science we do are with professional astronomers, but some of them are with amateurs, you know, citizen science, and you have a really exciting project. Tell us about it.
Yes, Thomas, the thing that excites me the most about this eclipse is that millions of people across the country in the path of totality can walk out on their porch, you know, in their slippers and collect world-class data. We don't have to travel to a telescope, a large telescope on the top of a mountain. We can go in your backyard and using fairly modest-sized instruments collect really important research data. So if we go to the first slide, the Citizen Continental America Telescopic Eclipse Experiment, or Citizen CATE experiment, involves over 200 volunteers stationed at 68 points across the country. They have identical equipment, and they'll take data during the eclipse. Now the key is, at any given site, you'll see the corona for about 2 minutes at one location. And the corona is big, it changes, but slowly, and in 2 minutes you really can't see changes that we want to study in the solar wind. But if we take data as the shadow of the moon crosses the country, and then combine that data into a continuous movie, we can observe the corona for 93 minutes, and therefore see changes that we wouldn't normally otherwise detect. So it's really exciting to be involved in this project. After the eclipse, the volunteers will keep their equipment due to the generous donations from the federal and our private and corporate sponsors. But right now, at this current stage, we had some students go to Indonesia last year and get on-the-job training at a solar eclipse. They came back to the US, and now they've trained all the volunteers for the August event in a series of 11 workshops. So our volunteers have their equipment, they're practicing on the sun and the moon, even as we speak, and getting ready for the day on August 21st. So how does this data fit into the big picture when we study the sun? We've heard that NASA has a fleet of spacecraft studying various parts of the corona. How does the eclipse data fit in? Well, if we go to the next slide, we'll see that some of the NASA missions have a data gap. And that's in the lower part of the corona where we really want to study the solar wind, where space weather can have a big effect. And so here we're superimposing our data from the Indonesian eclipse onto a set of NASA observations that shows exactly where our eclipse data will fit in. There's a lot of interesting physics and exciting things that go on. The sun is really hiding some science in that data gap that we want to get at. And that's what we're going to try to do with the eclipse data. You know, we talked a little bit about the space weather impact and how it affects us here on the Earth. When we're trying to understand space weather and solar storms, it's similar to understanding weather on the Earth. If you want to know if a storm is going to hit a particular city and when it's going to hit a city, you need to understand the wind on the Earth. And so in a similar way, we're studying the solar wind to try to better predict what happens in space with space storms, solar storms, and space weather. We know from our NASA measurements that the solar wind does accelerate a lot in this region, in this data gap, but we don't know exactly how that happens yet. So if we go to the last slide, everybody in this room accelerated today when you got onto a freeway. So at the bottom of the freeway on-ramp, you're going at a slow speed, and you hit the gas pedal in your car, and you sped up and then merged with traffic going at 60 miles an hour. We know that solar wind is doing the same thing in this region of the solar corona, but we don't have the measurements to show exactly how that velocity is changing. What is the acceleration? And so hopefully, after we collect all of our data with no clouds, we'll come back after the eclipse and tell you exactly what is pushing on the gas pedal for the solar wind in this part of the corona.
Yeah, it's really exciting research you're going to do with so many excited students, we hope, right? And hopefully our future colleagues too.
Exactly.
So what I'm going to do is, before I turn it over to Dwayne, just ask one question from each of you, and I'll just go in the same order as we just did, and that is, what do you expect is the most important impact from this eclipse? I'll start it with you.
Okay. For me, the most important impact of the eclipse is really an opportunity for us together to come together as a country. You know, everything that's going on in the country. In the earlier panel mentioned kind of the separation between science and the public. And I think this is a really amazing chance to just open the public's eyes to wonder and to get people thinking about really the most amazing natural phenomenon that happens on the surface of the Earth, a total solar eclipse. And to get people to wonder and just incorporate that into thinking about what's going on in our cosmos, and to come together in that very human way.
Great, sense of wonder. Linda, how would you answer that question?
I think that was stated perfectly, and the only thing I would add to that is what I said earlier, that this really is an opportunity to reach children that we haven't reached before with STEM education. I like to say that astronomy is a very democratic science. The same laboratory that arches over the sky for scientists is the same sky that is available to everybody, whether you live in cities or in the countryside, or no matter, you know, what part of the world you're in. And this is an opportunity to engage the citizenry in an incredible event that has shaped humanity for thousands of years. And if we can encourage more people to get into astronomy and space science, that's fabulous. But if what we do is excite people about science in general so that they're curious and they want to know more about astronomy, that's fabulous too.
Well, thanks so much. David, how would you answer it?
I completely agree with what Linda said about NSF is very concerned with building a new STEM workforce for the nation. And we're also looking for new users for our telescopes. And so astronomy is sort of a gateway to, you know, all different kinds of science. And so we think that this eclipse will be a wonderful opportunity to get people engaged in STEM education and STEM. And you know, will be better for the nation.
How about you, Angela Speck?
Well, so I love the stuff that's already been said, and obviously, you know, encouraging people to be interested in pursuing science is great. I'd like to go a step further. I think that one of the things that has happened in recent years is that scientists are seen as this, you know, kind of weirdos, and that we're not normal. And that the public in general is not necessarily a fan of science. And so I would like to generate science fans. And I just want to kind of qualify that a little bit. So I like football, and I mean American football, because, you know, with my accent, that might not be clear. I like American football, and I'm 5'3" and pretty petite. I'm never going to play American football. I know the rules. I watch the games. I can be, a Monday morning quarterback, all of that. But that doesn't mean that I'm ever going to be professional or even amateur, but I appreciate the game and I'm a fan. And so what I would like to see is that this is an opportunity to be able to draw people from across the country into being fans of science and really loving science, even if it's not something that they themselves practice.
All right, finally, Matt?
I agree with Angela, and you know, maybe even go a step further, is to get the equipment and the training in the hands of people across the country, and to enable them to continue with citizen science after the eclipse. We'd like to use the eclipse to capture their attention. There's no way you can avoid noticing a solar eclipse. It's a spectacular event. But then after the eclipse, we'd like to extend their interest further and keep them observing and engaging in astronomy.
Thanks so much, all of you. Dwayne?
Okay, I'm going to do a couple of things before we open the questions. First, I want to make a slight correction, and then I see that Angela here has some interesting items on the desk that she's going to share. So Dave at NSF, we've had an interesting conversation for a couple of days, and he has an incredible portfolio, and he does a lot more as program director, not just solar physics. So I want to just say his portfolio is larger as the program director in the Division of Astronomical Sciences. So. And Angela, you have some interesting toys there.
Yeah, so I wanted to show a great way of being able to observe the total solar eclipse. On the NASA website, there are actually 3D printed files so that you can download the file and find your nearest 3D printer. And there's one for every state. So this is my home state of Montana. And there's a hole in the center of each particular state. And what you can do on Eclipse Day for the partial eclipse is just hold your favorite state or your home state in the path of the sun, and it'll shine that hole on the ground. Oftentimes we call these pinhole projectors. And that way you can see what the path of the sun is, being blocked by the moon. So that's just another way, if you don't have a chance to get your hands on a pair of glasses, to interact, to see what's happening with the partial eclipse. So there's all the different states, and there's also one of the United States. That's a fun way to get your hands on the eclipse.
Excellent. Okay, if you're just joining us, we're here at the Newseum in our nation's capital, talking about the upcoming August 21 total solar eclipse across America. We have the scientists here. We're going to open it up for questions. Social media, hashtag Eclipse 2017. And we're going to start here. If you can wait for the mic. We have a number of questions on the phone, and of course, we'll go to social media. So let's see. Seth, you got your hand up, so here we go again.
Yes, thank you. Seth Borenstein, the Associated Press. For Thomas, to start with, can you give us a sense, at least in magnitude or figures, of how much more this eclipse will be observed scientifically, not by people, regular people, but by astronomers compared to previous ones? Is this going to be the most observed scientifically observed eclipse ever? And also for Angela, you talked about the wonder and the beauty of the high altitude balloons. This briefing is sort of about the science, I thought. What do you hope to learn besides just give us beautiful pictures? Is there something like what Matt has told us? What can we learn from high altitude balloons?
So what I'm going to do is try to answer your question first. So first of all, what we did for this particular eclipse at NASA, and you may have done similar things at the National Science Foundation, we actually had an announcement for opportunity that basically actually funded researchers to develop research programs associated with that eclipse. That's out of the heliophysics division, but also other research was supported through that. And so through that research, not only will some of the research focused on the corona be performed, but also new technologies will be tested that have the potential of perhaps flying on a balloon or in space later. So for us, this is the eclipse we're most focused on, and undoubtedly the one that will lead to the most researchers involved.
So to answer that question about the science the balloons are going to do, there's actually 3 pieces of science that we're focused on. We're really 2 different projects, one providing the live feeds and one looking at changes in the atmosphere. So normally the atmosphere experiences change with night and day, but the eclipse coming across the country in a dark shadow at an average about 1,500 miles per hour is going to set up waves in the atmosphere, and the temperature changes will also affect that. So we're going to have a series of weather balloons in many locations across the country that will launch every 15 minutes or so and be collecting information about how the atmosphere is responding. In addition, all of the footage that we'll get from the balloons that are doing the video and the still images, we'll be able to capture images of the clouds, which can also tell us information about how our atmosphere is responding to the eclipse. The second piece of science that's being done is all of our footage will go into a project called the Eclipse Mega Movie Project. And the idea here is that we know the exact surface of the moon from previous satellite studies. And looking at the Bailey's beads, which are just the last little bits of light before the total solar eclipse, we can actually use that data and collecting lots of different images to learn about the exact surface of the sun, actually. So using the moon's surface to learn about the surface of the sun. So that's the second piece. The third piece is that it turns out at high altitude where the balloons are going to be is an analogy in temperature and pressure to the surface of Mars. So we're partnering with NASA Ames researchers to fly resilient bacteria on the balloons to get a feel in many different balloons across the country, but all happening at the same time, what these bacteria go through so that we can learn that analogy for the surface of Mars. So NASA has done this kind of study on a NASA balloon before, but not on multiple balloons at the same time. So those are the 3 key pieces of science.
And just Seth, that's an interesting storyline by itself, those experiments. So for the media here, you may want to take a deeper dive in that astrobiology's experiments. I'm going to stay here for one more question, and we have social media folks if you want to do it, but we have a question here, then we're going to go to the phone lines. Name and affiliation, please.
Hi, Hanukkah Whitering with Space.com. Another quick balloon question, and then I'll have a follow-up. Are the GoPro cameras on the balloons also going to be pointed down towards the Earth and like watching the shadow of the moon?
That's a great question, and just a minor correction to the question. So the technology that we use actually is Raspberry Pi. So we have little Raspberry Pi computers. So the cameras are actually Raspberry Pi cameras. And actually, the teams will be looking at different things. So the cameras are actually controllable from the ground. There's really great, speaking of technology, that's a really interesting thing. We're cutting edge technology with so much that we're doing. So the teams can actually control from the ground through a satellite link and other radio links what the camera is looking at. And on most of the balloons, they'll have also cameras pointing in lots of different directions, so they can choose the camera as the balloon is spinning to look at what they want to. So we have some teams that will be wanting to look at the sun to see what's happening in totality. We have some that will be looking at the ground. For me personally, it's the shadow, like looking down on the Earth and seeing the shadow coming across, that is really the most spectacular. But the teams will kind of choose what they want to show.
And then so my follow-up is, with looking at the shadow, is there anything scientific that we can really learn other than, I guess, if you're looking at the atmosphere, is there anything about the shadow itself that will teach us something about the eclipse or Earth science or something?
I think that there is. I can't answer that question in detail. I'd have to follow up with you, or the person from NOAA on the earlier panel could probably answer that question in more detail.
Perhaps one possibility. Angela, are you there, Angela Speck?
I'm here.
Do you have an answer to that? Because you're thinking about these shadows and the atmospheric effects a lot.
Right, so there's a couple of different things. One of the things is that, we're now at the point where, as we're looking at the shadow and understanding exactly where it's going, being able to see it from the outside and the inside at the same time, that is going to have an impact on how we're looking at atmospheric effects. But I'm not sure I think your question was the shadow itself. And I think what it's going to do is test an idea that was put forward for how we determine the shape of the shadow. So there's some interesting effects that happen to do with the fact that, as the other Angela said, you've got these craters and mountains on the moon that give rise to Bailey's beads. But they also mean that you get this really interesting visual effect that the shadow of the moon is not actually a circle, and in fact it's not even just a stretched out circle, it's kind of an irregular polygon. And so having data that's letting us see the shadow in all directions is going to help us see how well did we do in working out what that shadow was going to be.
Excellent. We're going to go to the phone lines first, and then we'll head over to Jason's corner there with the social media and all of the traffic all over the world, actually. Preparing for the August 21 total solar eclipse across America. On the phone lines, who's up first? Rebecca, Atlantic. Rebecca, are you there?
Oh, hi. Hi, can you hear me?
Loud and clear.
Okay, I guess I went away while you were calling on me, so I didn't know my name. Sorry. I guess I have a couple questions. I'm wondering, first of all, why you all think this will be an event that excites people and gets them interested in science. If you can explain, I guess, what your thoughts are about that. Anyone who's experienced one of these or has not but is looking forward to experiencing one of these, what about this event will create that kind of inspiration for people?
I want to start with you, Matt, perhaps, before I go to Angela on the phone.
Yes, so I've only seen 2 total eclipses, and I've seen it by trying to do science at both of them too, so my perspective may be a little skewed. But first of all, the corona, I think, is the most beautiful thing you can see in the sky. It's much more beautiful than planetary alignments or even comets that I've seen. The corona is just fantastic and filamentary and delicate and awesome. The second thing is that in the middle of the day, the sun is not supposed to go away. So you get this sort of primal feeling that something is wrong. This is just not supposed to happen. It's a wonderful way to understand where we fit in this cosmic perspective that Thomas mentioned before. You can actually get a three-dimensional sense of where you're at. And so I suppose, if you're really, adamant about not being affected by the solar eclipse, you might be driving down the road and try to ignore it and turn on your headlights. But I have a feeling that about 90% of the people in the path are going to be just awestruck with this event.
Angela, anything to add?
Yeah, I mean, I think that what Matt said is great. We have, we know that people are affected viscerally by this. It's such an, the change in light is so fast and what you get to see is so amazing that even people who chase eclipses and have seen dozens of them will still be wowed by this. They'll still have this intake of breath as it happens, and people are excited about the idea. I think this is one of those things where even if you haven't seen one, you're aware of the concept. And once you start to hear more about it, people get excited. I've been going all over the country doing talks, trying to help people get excited, but also get ready because it's going to be such a huge event. And there'll be people like, I wasn't sure, but then I heard you talk about what's going to happen, and now I'm really excited. And that's people who haven't even seen one yet. So, I think that what we're going to see is there'll be people who, it's like, this really is, for a lot of people, a once-in-a-lifetime opportunity. It's expensive to travel the world following these things. And so they will make the effort to come and see it, and then they're going to be so blown away by just how amazing it is and just the overall feeling of it's not just visual, it's an all-over experience, that they will be changed by it.
Next question on the phone. Taylor.
Hi, can you guys hear me?
Loud and clear.
All right, I'm from WKMS. We're an NPR affiliate station in West Kentucky. What we wanted to know is where is NASA going to be posted during the eclipse? We've heard rumors about you guys coming to West Kentucky where the greatest duration of totality is going to be. We just wanted to know where you guys are going to be posted.
This is Thomas. What I'm going to do is kick it over to Alex. He's our expert who has been thinking about the eclipse for how many years?
A lot of years. So NASA's got a lot of places across the country, starting in Salem, Oregon, moving all the way down to Charleston. But we have places in Wyoming, in Idaho, in Nebraska, in Illinois, in Missouri, in Tennessee, so in Kentucky. So what you need to do is go to eclipse2017.nasa.gov under events, and there you will find a Google map with all of the television broadcast locations, the education outreach locations, as well as all of the different people who have registered their events to share with NASA and to share with everyone in the country about what's going on. So there's a lot of official NASA sites as well as lots of other ones that NASA is helping to support and promote.
And let me just add that we've got a total of, I believe, 8 types of things happening in that area. Phenomenal things happening. Want to ensure that you go to the website to get the specific details. And Charleston, that will be Eclipse Central. Right now, that's what we're calling it. That name could change, but Charleston will be our home base. As I've been talking about, as you heard in the first show, nasa.gov/Eclipse Live for the 3-hour unprecedented NASA TV show through the eyes of NASA. Charleston will be our home base. Western Kentucky, a lot of things happening. And if you want to follow up with us at NASA, we can give you specifics. But as Alex said, lots of things across the country, but particularly in Western Kentucky. Any other phone questions before I go to Jason? And then we're going to wrap up. Chelsea on the phone.
Hi, Chelsea Bayarte from GeekWire.
We hear you.
I would have a question for Angela. So you had talked a lot about student research and the involvement with NASA Space Grant. Will the removal of the Office of Education reduce student involvement in the future for research?
That's a very interesting point that you bring up, and I'm obviously working very hard with folks at NASA and also with our legislatures to make sure that our really valuable education programs do continue to exist. So obviously, if that elimination happened, that would have a huge negative impact. As I said, this is a collaboration amongst many different NASA entities, the NASA Science Mission Directorate, NASA Space Grant, and there's lots of different centers involved as well. So that's something that we're really working on. I mean, as we speak, literally our community to save the important parts of NASA education. If things need to change a little bit, we understand that, but we're working very hard to maintain those really impactful programs.
Okay, we're going to take one more question on the phone, and then we're going to go to social media, and we'll wrap up. And I believe we have CBS News. Bill?
Yeah, hi. Thanks. And I might have missed this earlier, but we talked about satellites that will be observing it, the balloon campaign. Do any of you have a sense of how many observatories, professional telescopes that will be studying this thing while it's happening, even ballpark? Just curiosity. Thanks.
Go ahead.
So the way I would answer that, we're going to start with the NASA number first. We have 11 spacecraft that are going to observe, 2 of which, of course, we're doing together with our sister agency at NOAA. We have, in addition to that, well over 50, balloon platforms. We have 3 aircraft, and I'm really interested in your answer, David, later. But I think there are really thousands of ground-based observatories, a variety of professional grade that will look at this, just of the type that you talked about, Matt. Telescopes that are out there that you helped disseminate, but also others. But David, how would you answer it?
Yeah, well, unfortunately, our major national facilities are located in Arizona, New Mexico, and soon to be in Hawaii. And so our major national facilities, ground-based facilities, won't be able to observe it. But there's Matt's project. We are also funding another project where they're going to observe it from 5 different sites in the path. And then I also described the NCAR air flight that we're sponsoring through the National Center for Atmospheric Research.
So, Bill, we'll see if we can get you a number. If we say a whole lot, that probably won't cut it for you. So this is why it's good that we're doing this 2 months out. We can get these questions. And again, the questions we can't answer, and a lot of things we're still confirming up. But we'll get those on, as I said, Eclipse 2017. Okay, we're going to go to social. And Jason, let's take a few questions before we wrap up.
Indeed. Thanks, Dwayne. Just a couple of things here coming in. There's a lot of folks who are concerned about pets and animals here. So there is a friendly reminder from one of our social media participants out there who says, don't forget to leave your pets in your hot cars during this. Take them out and so on, so that way there's no safety issues there. But the other person here is asking us, Terry on Twitter is asking, how will this affect the big critters out there, things like grizzlies or moose?
I could take that one.
Angela Speck, do you have an answer there, or I've never met one of those, and during an eclipse.
So actually, I'm up in Wyoming in bear country right now. So I can certainly talk to this a little bit. So I think that, first of all, I want to address one of those earlier comments, which is that, you know what? It's no different than any other day. On a normal day, your pets don't try to look at the sun and therefore don't damage their eyes. So on this day, they're not going to do it either. It's not a concern letting them outside. It is all that's happened is we've blocked out the sun. It's not more dangerous. So I think that people who have pets want to think about that. I'm not going to worry about my cat. But for the big beasties, I'm up here and we've got things like mountain lions and bears and wolves and coyotes. And a lot of them have nocturnal activities. But the nighttime comes so fast, and I don't think we have good data on this. So it's actually going to be really interesting to actually see what happens. Because remember, we go through a period of maybe half an hour where it's kind of early twilight colors, and then it goes to quite dark very fast. So depending on how fast an animal reacts to it becoming dark, it may not be an issue at all. But one of the fun things is going to be that this eclipse goes right over the Tetons National Park and across a swath of Wyoming, and there are a lot of bison, bears, other beasties, rattlesnakes, all that sort of thing, where we don't actually have much data on that.
it getting dark out there. On Facebook, user Jessica is asking here, is it going to get dark like night out there during the eclipse?
It gets to be about as dark as it is about a half an hour after sunset. So a deep twilight is what you'll experience.
In the path of totality.
Sorry, yes. Yep.
All right, wonderful. And then Twitter user Brandon here is asking, what are the differences and similarities between the solar eclipse coming up in 2017 and the solar eclipse of 1979 for those who are around to experience it?
Angela on the phone, do you have any opinion there, or perhaps?
Okay. Well, so in terms of the way that this is going to affect the country, it's huge. I would have been in like second grade in 1979, and I certainly wasn't under the path of totality. But if we just look at where the path went, that only hit a small corner of the US. This one goes all the way from coast to coast. It's very accessible from people all over the country. So we have lots of opportunities.
All right, Linda on the Linda on the phone. I'll get to you.
No, actually, I think Angela answered that one pretty well. I think it's the coast-to-coast nature of it that's really spectacular, and I think people have mentioned all of these opportunities to stitch together all the photographs and all the images of the eclipse from coast to coast is a really unique experience.
One more. Jason.
All right, last question here comes from Twitter user Emily, who asks, when will another phenomenon like this occur? So.
It'll be in April of 2024. The path will go north to south, but it'll cross Mexico, the United States, and Canada.
Okay, so what I'm going to do here is, you're hearing all of these incredible stories, and it really reaches down on the soul and the personality and the human seeing nature. But there's also some really personal storylines here, and I'm going to go over to you, Matt, about how your name of your organization came about.
Oh, yeah, I happen to have a 14-year-old daughter who has the same name as the project. And I'd like her to grow up to be a nice citizen, so that's how we came about with the name.
Fantastic. So we're 2 months to the day, everyone, and all viewing here. The total solar eclipse across America, August 21. Early in our briefing, we gave a shout out to the U.S. Postal Service. If you didn't know, they came out with a first-of-a-kind stamp. And go out, get those. They're great collectibles. They've been selling them here at the Newseum. You can get them at your local post offices and online. All of this information, again, you heard a lot of websites at the NASA website, so we can put those up again. We want to commit those to memory, very important. Eclipse 2017, everything on Eclipse A through Z. If it's not on there, it will be on there. We got 2 months to put it up. You call us. And for the live broadcast with the space station, with the unprecedented unique advantages in space, on the ground, in the balloons, and everything in between, Eclipse Live, nasa.gov/Eclipse Live. I want to thank the Newseum again. I want to thank our panel. Can we have a round of applause for the scientists, please? For the social media, keep those questions coming in. We have a team of scientists that we will be answering questions almost on a daily basis, and I know the pace will pick up. There's some plans to do an additional briefing to give you even more details on the assets in the space station and others, and we'll probably have some other agencies join us. So before we go, we're going to do what we did last time for the folks out there. Safety, get your glasses. You heard some other options. We want to be safe. We want to be prepared. The eclipse is coming. Mark the date. And remember, science never sleeps.